Welcome everybody to our presentation. This is business math course. We're going to discuss logarithmic differentiation. This is Magda Talib Al Hinai from Sultan Qaboos University and I welcome you all to our presentation. Usually we presentation with an example. Here is the example, differentiate y equals, and we have a rational function where in the numerator we have a bracket cubed inside which there is 2x minus 5. In the denominator we have an x squared multiplied by the fourth root of x squared plus 1. And we're asked to find dy by dx or y prime. We start our solution. In such a problem, we can easily go and do the quotient rule where we have a u in the numerator and the v in the denominator. In the denominator, we also have to use the product rule because we have the product of two functions. And on the go, we will be applying the chain rule for these functions to be differentiated, the bracket cubed and the bracket power 1 over 4. So we are applying chain rule, product rule, quotient rule to solve this problem. It can be solved and many of us would like to do it this way. Now we are introducing a nice way where we take the logarithm, the natural logarithm of both sides. We take ln of y and ln of this rational function. So let's see how we are going to do this. We have y and we have the right hand side here in front of us between which there is an equal sign. Take the ln to both sides. Yes. So we have ln y is equal to ln 2x minus 5 all cubed over x squared, the fourth root of x squared plus 1. Now we will start applying the properties of logarithms which we know for this part. We know that ln a over b is equal to ln a numerator minus ln b the denominator. So here we go. Yes, ln the numerator minus ln the denominator. But here we have the product of two functions. So we are going to use another property of the logarithmic functions. But first of all, I rewrite this as a bracket power 1 over 4. So here is the property of ln a times b. I will apply it here. This is the a and this is the b. So it will be equal to ln a plus ln b. So the first term will count down as it is. And here the minus sign, we have it, ln a plus ln b. Next, we will apply a third property of logarithmic functions where ln a power c is equal to c ln a. Any exponent, we will bring it down. The 1 over 4 will come down, the 3 will come down, and so will the squared on the x. So here we have 3 ln 2x minus 5 minus, I open square bracket and I put 2 ln x for ln x squared plus 1 over 4 ln of x squared plus 1 where I got the exponent 1 over 4 down here. So this is the ln y. This is the equation which we will differentiate both sides to get the y prime. What's the derivative of the left-hand side? Yes, the derivative of ln y is 1 over y into y prime. Now let's move to 3 ln 2x minus 5. What's the derivative of 3 ln 2x minus 5? The 3 is outside. Here I have 1 over inside times derivative of inside, which is 2. So we get for the first term 3 multiplied by 2 over 2x minus 5. Now we move to this term minus 2 ln x. Okay, yes, it is minus 2 over x. Yes. And then we move to 1 over 4 ln x squared plus 1. It is 1 over 4, 1 over inside times derivative of inside. We see this here, yes, minus 1 over 4 because we got the minus sign from outside. And we multiply it by the derivative of the logarithmic function ln x squared plus 1. It is 1 over x squared plus 1 multiplied by derivative of denominator, which is 2x. Now we want the y prime on one side and the other side is containing the x's. So here we have y prime is equal to, we multiply both sides by y, so here we have y prime is equal to y multiplied by 3 times 2 is 6 over 2x minus 5, here is the denominator, minus 2 over x, we have it here. We cancel this 2 with the 4, so we get x over 2 into x squared plus 1. And now we will take this y. We know it's given up there here. We will plug in the value of the y. So this is equal to, yes, we put the y. And then here comes this whole bracket. Yes. So this will be the derivative y prime which we are looking for. Of course, these steps where we use the properties of logarithmic functions made the differentiation much easier than just applying product rule, quotient rule, and the chain rule, and then simplify to put your answer in a simplified form. So this is one way. This problem can be solved either using the traditional way of product, quotient, chain rules, or by using the logarithmic differentiation. But in the coming slides, we will see that the logarithmic differentiation is not optional, as we saw in this example. Some examples we are forced to use nothing but the logarithmic differentiations, and this we will see in the coming slides. Okay, everybody, let's see the coming few examples. We start with an example, differentiate y equals 1 plus e power x all power ln x. We see a function to the power of a function. So here we have to use the logarithmic differentiation. We take the natural logarithm to both sides of this equation. We will have on the left-hand side ln of y, and on the right-hand side we will have ln of 1 plus e power x all power ln x. This power in the exponent will come down using the properties of logarithms. So we will write ln y is equal to ln x, which was in the exponent, multiplied by ln of 1 plus e power x. This is equal to the product of two functions, so we take this into account when we are differentiating. We differentiate both sides with respect to x. On the left-hand side, we will have the derivative of ln y to be 1 over y multiplied by y prime, or dy by dx. On the right-hand side, we'll start applying the product rule. The derivative of ln x is 1 over x multiplied by v, which is ln of 1 plus e power x. This is it for the first term. Now we will take u into v prime. U is ln x. V prime is 1 over inside times derivative of inside. Let's see it. Yes, here we have the ln x for the u. Here's the 1 over inside. Here's the derivative of inside. Next, we simplify, and we will write this first term as ln of 1 plus e power x over x. And for the second term, we'll take the ln x multiplied by e power x and put it in the numerator. The denominator is the 1 plus e power x. Now, we see that we multiply both sides by y, so we get y prime is equal to y multiplied by the bracket we just got here in this step. So in the coming step, we will take the y and replace it by the given value of for the y, which is f of x, which is 1 plus e power x all power ln x. Okay, so we write for y, it's given 4, and then we put the bracket as it is, and this will be the. Now we move on to another example. Differentiate y equals x power x. Also here we have a function, power function. So we have to use the logarithmic differentiation. We will take the natural logarithm to both sides. So we will have on the left-hand side ln y. On the right-hand side we will have ln x power x. Again, we apply the properties of the logarithms and we take this x down. So we will have ln y is equal to x ln x. Again, we're having a product of two functions. So we will start differentiating the left-hand side so that we get for the left-hand side 1 over y into y prime. For the right-hand side, we will have u prime to be 1. The derivative of x is 1 multiplied by v, which is ln x, plus u, which is x, we put the x as it is, times the derivative of ln x, which is 1 over x. We cancel this x with the x here, so we will get 1 over y into y prime is equal to ln x plus 1. Next, we multiply both sides by y, and then we put y in its given form, which is x power x. Now, let's summarize the steps for logarithmic differentiation procedure to differentiate a y equals f of x. First of all, we take the natural logarithms of both sides, so we get ln y is equal to ln f of x. Step number 2, we simplify the right-hand side, which is ln f of x, using properties of logarithms. Step number 3, we differentiate both sides with respect to x. Step number 4, we solve for y prime. Step number 5, we write our answer in the form of x only. We replace y by its given value f of x.